Hello. So, we will continue our discussion on cloud computing, rather we will continue our discussion on fog computing. So, what we have seen in our previous lecture or previous discussion on fog, that there is a need of several application to instead of pushing all the data, services and applications to the cloud, instead whether you can do at a much lower level, right. There is some of the requirements are due to the bandwidth limitations, like or reducing the bandwidth overload, and in some of the things are real time applications, right. You need to do some real time applications which instead of pushing everything to the cloud, getting the feedback process etc to end of the edge of the network may take much time, right. So, in order to handle this, we need to push, or there is a requirement of pushing some of these functionalities to the edge of the network or at intermediate level, right. And also we have seen that not all cases we require everything to be pushed into cloud, right, like especially applications like connected vehicles or your that street light or traffic light management, where it is more localized, the phenomena is localized, right. So, it is more deal with the objects which are in nearby spaces. So, it is not there is not much requirement pushing all the data to the things. Again, with the huge proliferation of sensors and for that matter IoTs, there is a huge volume of data generated, where instead of sending the raw data to the cloud for processing, we can do a pre-processing, or what we say some sort of a aggregation of the information and push it to the cloud for further processing. So, overall in looking all those things, there is a need to bring this data, services, application little down from the cloud, what we say fogging or fog computing. In some cases also people say as a edge computing, or having a distributed phenomena of the things. There are few characteristics which we have looked into of cloud which need to be served here also, like scalability, infinite scaling or scaling, pay as you go model or metered services, and that like making the infrastructure free type of situation of the things, and several other characteristics what cloud provide. What was the major motivation of moving towards cloud need to be supported by the fog also, right. So, that is the need of the things, and it is not like that all given a particular application A, everything should be put on the edge of the things. There may be we can do a partially at the cloud end and partially at intermediate or edge of the network, right. So, this will bring different sort of challenges what we will try to look at in today's talk, that what are the different type of things, what are the fog equipment, fog devices are not so resource rich, right, like they are devices like intermediate routers, or at times the sensing devices or the sync of that particular sensor deployment, sync node of the processor deployment, which is not as resourceful at the cloud, not nowhere as resourceful at the back end high resource cloud. So, there is a resource management comes in a big way of success of this type of phenomena, right. So, we will talk about fog computing. So, what we see that cloud computing has been able to help in realizing the potential of IoT devices or IoTs by providing scalability, resource provisioning, as well as providing data intelligence from the large amount of data. So, one is the scalability, resource provisioning, and the other end it can basically do some sort of a knowledge mining from the data, right, making data to from data to knowledge transformation sort of things, right. That is at the back end we have machine learning and other type of algorithms which can run. But the cloud has few limitations, like specifically in the context of real time latency, right. Response required in seconds or milliseconds or microseconds sensitive applications, like in case of a say application accident, say if there is a collision of the car, and if there is this cars are intelligent car, what we say that having which are VANET enabled, vehicular ad hoc network or sort of things, if we need to push this cloud this collision related information to the cloud, get it refined and find out the location etc., inform the nearby cloud, that may be a, by that time there may be few more or many more applications accident could have happened. So, it could have been done in a very localized manner, where instead of taking it to the cloud and doing the processing, I could have done at the localized manner if possible. So, this sort of real time applications where this accident management or some other type of applications, what we see that can be a possible phenomena of doing that. So, fog computing has been coined in order to serve real time latency sensitive applications faster, right. It has been coined to serve real time faster. Fog computing leverages the local knowledge of the data that is available to the fog and draws insights from the data by providing faster applications. So, first of all is a order to serve real time latency or real time applications, or which are time sensitive applications, and also it leverages the local knowledge of the data more at the local level available to the node and draws insight from the data by faster response, right. So, that exactly it tries to look at that fog sort of environment. Now, this picture we have seen in the earlier our discussion on fog, like we have one in cloud, one in these sensors and mobile devices and other what we say contributing to who are contributing to the data. Intermediate devices can constitute this fog, right. So, this is this may not be specially installed for that, right. So, we are having say routers or gateways, some systems and other devices which are basically communicating to the which are basically used for intermediate communication of the sense data to the cloud, right. So, transmitting they are more as a some sort of a working as a store and forward from there, whether we can do store, process, forward and take some call locally, right. Some of the things need to be forwarded at the other end for higher level of things, or maybe aggregation over a larger geographical space when different sensors coming from the things. Nevertheless, we can have a localized phenomena what we look at the using the data at the local level. So, what we see that more computing power, more storage is at the end. So, the applications which are more computing intensive can be pushed to the other end, whereas more interactive or more responsive can be at the lower end. So, these are the two side of the things. So, intermediate we have fog, or even in some cases this front end devices can do some sort of calculation and aggregate the data and send to the things. So, if you look at if we try to compare or compare and contrast between cloud and fog, as we have discussed earlier discussed in earlier lecture, that these are not competitive, means in the sense they are not replacing one by another. So, what it is trying to do, it is more of in a companion mode, right. Some of the things which can be done better in cloud and should be done there, and fog, and they should do in a proper orchestration of the things, a much requirement of the orchestration. So, if you look at, if we try to look at requirement of cloud and fog, so if we say latency, so is higher in cloud or lower in fog, right. So, latency is a higher. Delay jitter, definitely if the latency higher, usually it is high, and it is very low in the fog or low in the fog. Location of server nodes within internet, right, whereas at the edge of the local network, right. So, where the server nodes are located in case of a cloud, it is in the internet, right. You really do not know that where the services are given. You talk about Amazon or Google or Microsoft or IBM or anything, Salesforce or anything. So, what we do, we basically connect through their portal or link, and we really as a end user do not know that where your application is being done. It is not like that you cannot know, you can know, but nevertheless they do on their resource management and provisioning and type of things. So that is what we say in the internet, whereas if you look at that fog type of scenario, so it is more on the edge in the local network. Like if I am doing say aggregation of the temperature sensing and taking a decision of this particular room which is having say 10 odd sensors, then what I am doing is basically locally, and I know that the server in this particular room is working for that things, or the server which is serving for this particular room is working on the things, right. At times that is useful, because if you see some congestion or some problem in the things, you can address the things. At times there are other challenges, it may be a security loophole also, because you know if the temperature is being sensed by the servers and it is sending things, and if this particular lab or room is housing important other systems, then I can basically attack that server and say that do some malfunctioning, right. Even the temperature or means environmental sensing is giving some alert, I say that everything is going on fine, and attack type of things. So, there are downfall and type of things required, and secondly it need to be resourceful to cater to the type of applications which I am trying to run. Distance between client and the server, usually in case of cloud computing is multi-hop. You are using this standard networking to go to the thing. Usually in case of a cloud it is a one hop, in case of a fog it is a one hop, right. So, they are at a one hop distance from the client to the server, right. Security, in case of a cloud computing, one argue that it is undefined in the sense that as the user end I do not have much control over the things, right. So, it is in that sense it is undefined, whereas here it can be defined, like you have a local things, you may have some control over the things. So, user may have some control over this particular devices, or the organization can have control over the devices and can try to ensure some security. Like if I say the traffic light, so the of a particular city, then the traffic light management in that server of a particular zone is under the traffic authority of that city, right. So, they have a control. Had it been on the totally on the cloud, so you do not know that what the data or applications are doing, that is based on that service provider. Attack on data enrouter, right. So, when the enroute data, whether the attack in case of cloud, if there are multiple hops, so there is a chance of much become getting much compromised, where in case of a fog, if it is a single hop, then as it is a single hop, then the getting compromised things are less, right. So, you have a little more control over the thing. Location awareness in case of a cloud computing is minimal, whereas edge fog computing is location aware. It is primarily what we are doing is location aware type of things. So, there are other things like geographical distribution. In case of a cloud, it is more of a centralized feeling. So, it is having a logically centralized things. In case of a fog, it is distributed, right. Number of server nodes in case of cloud are few, because that is at the cloud end, and usually servers are extremely resourceful. The number of nodes required for that applications or type of things are very few. In case of a fog, as it is the edge, as you go down the hierarchy, that the number of nodes increases much more. So, they are the very large number of server nodes. Support for mobility in case of a cloud is limited, right. If you move from one or mobile application, that it need to be switched, etc., to the different intermediate devices. Now it is carried by, say, one path once you move to the other path, whereas in case of a fog, some sort of support is there in the mobility, because it takes a local decision of the things, right. It knows a priori things are that is where, under which control, and need to be transferred at a much lower level. Real time applications, real time interactions do supported by cloud, and of course it is supported by fog. That is one of the major motivation to move towards fog computing scenarios. Type of last mile connectivity is usually lease line, right. So, or cable line in case of cloud, right, whereas in case of a fog is usually wireless, right. That there is no hard and fast type of things, but these are usual standard processes in reality, right. So, there are pros and cons. It may so happen that as we are discussing fog, so it is little bit more supportive towards the fog why it is there, and but nevertheless, though both has importance, and proper synchronization or orchestration between this fog and cloud should make the whole thing a reality. So, there are several use cases, right, or several scenarios where fog will be very much applicable. One is that emergency evacuation system for any catastrophe or disaster, real time information about currently affected areas of buildings and exit route planning, etc. So, if it is a large building with several route paths for exit, if there is some catastrophe like fire or earthquake or something, then the default paths may be getting locked, right, or may not be routable. So, what you need to do? You need to do a, based on that availability of the exit at every level or every individual rooms, etc. We need to plan the path. So, it need to be dynamically replaned or rerouted, and where maybe some local decision is much more helpful. Natural disasters management. So, real time notification about landslide, flash flood to potentially affected area. So, that is one requirement. So, when we are having national disaster management, so real time notification things are there, which are sometimes pretty localized, or a particular region of interest where the things are going on, and maybe useful way if we have this location aware information at a fog level. So, large sensor deployments generate a lot of data, which can be pre-processed, summarized, and then to send to the cloud to reduce congestion in the intermediate network. So, that is another requirement of fog. It may not be natural disasters management or natural disasters or hazard, but in other sense what we have that huge deployment of sensors that can have produce lot of data, and it takes, if you send all the raw data to the cloud, it takes a lot of bandwidth and lead to congestion. So, which can be reduced by pushing aggregated data, and of course, the Internet of Things, right, based on big data applications like connected vehicles, smart cities, wireless sensor network, actuator networks, and those and etc. So, these are all different what we aspects of, or the scenarios of Internet of Things, which again puts lot of data and in the whole framework, and all every time that this may not be important, like that maybe a local decision is more important than taking a global decision and type of things. And if we look at the applicability, there are few here, there are 100 more which can be there. So, smart traffic lighting may be one application, connected vehicles, smart grids, of course, sensor network, Internet of Things, and software defined network. They provide this backbone of these applications to work on, right. So, if we look at the connected vehicle deployment displays rich scenario of connectivity, cut to car, cut to access points and type of things. So, what we look at when we talk about vehicular infrastructure, we have on the road different moving cars, right. So, so these are different vehicle and of course different infrastructures. So, we have connectivity between this vehicle to vehicle, or what we say V2V or V2I, I2I. So, these are different infrastructure which are hovering around and giving connectivity to these different vehicles. So, this sort of things are different type of application. One is safety related applications, another is say information or infotainment, information related application, and there are other things like alerts and other type of things based on the type of. So, those are the informations which will be there, and in C there may be a overall cloud infrastructure where all could have communicated, right. And it takes a decision and sends back information type of things. Now, say there is a crash in this particular vehicle, right. If there is a crash, then other vehicles which are approaching this vehicle now get a information via this. Instead, it could have been done locally, right. If I can set up some sort of a fog around this sort of things, then I could have taken a local decision, because the accident here may not be nothing to do with some road going somewhere in some cities, etc., right, or even in the same city some other part of the things. Now, here this type of connected vehicle phenomena, or what we say a concept which is coming up or it is already there, VANET, vehicular ad hoc network, right. So, to make it successful, this fog may be one of the applications, right. So, again smart city lighting, as we see that if there is a traffic congestion, etc., that within the thing within that particular localized things city. So, fog has a number of attributes that make ideal platform for connected vehicle in providing services like infotainment, safety, traffic support and analytics like geo distribution, mobility, location awareness, low latency, heterogeneity and so on and so forth. So, there is a lot of applications are there. So, like what we see that there are different vehicles running at the back end. So, there are the access point, or what we say that infrastructure along, or sometimes known as roadside unit or RSUs. So, these units are there are other traffic lights. So, based on this congestion, etc., this traffic light can be intelligent, like it gives the timing for stop and go type of things may vary based on the congestion level. So, and at the back end we have that cloud which takes larger analytics problems which requires larger resources, and we require a fog orchestration and network management layer which takes care of this synchronization or orchestration of the fog and also orchestration with the back end cloud. So, it is a system. So, what we try to see that this fog take a local decision, whereas larger analytics can be pushed to the cloud environment, right. So, this is one of the scenarios. There, of course, if we look at more of a Internet of Things. So, at the lower end we have embedded systems and sensors, then multi-service edge which takes that distributed intelligence where fog can play a role, and then we have a core network which is used to push the things at the upper cloud, right. So, this is in generic way of looking at the Internet of Things, where we see that a fog layer may help in reduce latency and providing better services. And though in our country may not be highly proliferated, or it is not in a big way used, but it is going to come, is that smart grid, right. So every home will have a smart meter, and based on utilization of the things at a from the home level to from at the house from unit of the house to as a region level and a larger state level, the overall management can be done. So I have a smart grid which not only give power to the homes and offices and installations, also take a feedback and takes a call based on the things that how the power utilization are there, and it is connected to the power plant, and the overall power management across the region, across the country or across a larger geographical space can be managed by this sort of things. So here also fog plays a important role. If you are looking as a all things can be pushed into the cloud and take a call, right? However, suppose I consider IIT Kharagpur, if the homes are having smart meters, then I could have taken a local decision that what is the overall utilization of the power and type of things, and I send a aggregated information to the backend cloud, right? So which takes a more takes up this aggregated information and do analytics that over larger time span or over days, months, etc., how things varies, and take a call that what to provisioning of electricity based on the things. So this type of things are useful where we have that end devices or end consumer of electricity, then we have a fog infrastructure where microgrids and other things are there, and then we have a macro station and push it to the larger sort of a cloud environment. And as we see that what we say lucrative or golden side of the fog, there are few definitely challenges, or there are good amount of challenges in order to have a realization. First of all, these devices are not that resourceful as cloud or cloud servers, etc. So they can give a what we say support to a minimize things. So if such application is there which require much larger things, so you need to divide the application accordingly, right? So it need maybe among the fog devices, some portion on these fog devices and some of the cloud. And whenever we do this, there is a lot of need of synchronization, orchestration of the things, right? Because not only now the data are divided, your application or the process is also divided. So somewhere this aggregation of this data and processes need to be there. So that is one of the challenges. There are other challenges of the resource management in the fog itself. Like suppose if one of the fog device is overloaded, whether I can migrate this application on the things, whether I migrate this on the live, like executing things can be migrated to the things. So these are serious challenges if we need to look at the things. So let us see some of the things. So fog computing system suffers from issue of proper resource allocation among applications while ensuring end-to-end latency of the services, right? So what we want to do, that end-to-end latency and challenges are faced. Resource management of the fog computing network has to be addressed so that the system throughput increases, ensuring high availability as well as scalability. So the basic phenomenon of the fog. And finally, as these are distributed over different geographical space, maybe with different authorities, then what about the security of this application and data and type of things, whether that becomes a source for things. So security aspects we discussed last lecture or last discussion on fog, that this is a serious challenge. So resource management in fog network so has different aspects, the utilization of idle fog nodes for better throughput, whether there is possible that some of the fog nodes it is basically skewed, some nodes are more loaded than others. More parallel operations, how to generate more parallel operations, handling load balancing, meeting the delay requirements of real time applications, right? So if you have a real time applications, how it can be provisioned properly, provisioning crash fault tolerant and type of things, right? Like I can say that if the fog node goes down, what will happen to those applications and data and which are running on that fog nodes, how to handle those, how to migrate those data, whether I require a priori application that even if it goes down the other will take up, and all those things require a resource management and incurs cost and so on and so forth. more scalable systems. So, at the scalability is our core of the whole thing, right. Scalability is one of the major aspects of cloud vis-a-vis fog computing. So, how to have better scalable systems. So, they are if we look at little more nitty-gritty, data may not be available at the executing fog node. So, the application is there, the node may not be there. Therefore, data fetching is needed from the required sensor or data source. So, that is a fetch cycle is there. Executing node might become unresponsive due to heavy workload which compromises of the latency. There may be a issue. Choosing a new node in case of a microservice execution migration, so that the response time gets reduced. Even if I have a way of migration, if I am a microservice is running on a particular node or a smaller or cut down version of the service or chopped service or a partition service is running, if I am able to migrate, that I see that this node is going down, what should be, where I should migrate, how to find a node at a thing. So, some algorithm should run and type of things, and some sort of a management should come into play. Due to unavailability of executing node, there is a need to migrate partially processed persistent data to a new node. So, it is half-cooked thing need to be migrated. So, that is another need. Final result has to be transferred to the client or actuator within less amount of time. In doing so, I should not lose out on the time. Deploying an application components in different fog nodes, ensuring latency requirements of the components. Multiple application may co-locate in the same fog node, right. Therefore, the data of one application may get compromised by the other. So, it may happen that number of application, more than one application in the same fog node. Data security and integrity of individual application and resource application has to be ensured, right. So, what we look at the multi-tenancy problem in the cloud, that sort of problem can be there in the fog, and fog is less resource full. So, that the problem may be more escalated. And there are several approaches people try to follow, like executing migration on the nearest node which is available to the thing. So, the nearest node which is free, it may not be the most suitable, but the available node type of things. Minimizing carbon footprint of video thing, my major objective is that to reduce that energy or carbon footprint. Emphasis on resource prediction, whether I can have the approaches prediction, resource estimation, reservation, advanced reservation, as well as pricing of the new IoT applications. So, whether we can do a priori estimation of the things. There is another services which we say Docker as an edge computing platform. To deploying Docker may facilitate fast deployment, elasticity, good performance. So, there are resource management based on fluctuating relinquish probability of the customer, resource prices, etc. People follow that. There are other things like studying that base station association, task distribution, virtual machine placement, and so on and so forth, and formulating ILP formulation to optimize the thing, or applying heuristics algorithm to approach that problem. So, these are the different type of approaches which people are trying to do, and you can see there are a lot of research motivation here, right. There are a lot of research going on, and those who are interested, this is a field where which can be looked into, or you can work on those type of aspects. This is a ongoing, rather upcoming area to look at. And security issues already we have discussed, I am not repeating that. So, security, what we try to emphasize here, security is also a major challenge, right, because low resource you cannot run say resource pool, or what we say resource hungry security applications, what we say, which or security measures which are resource hungry. So, you need to be appropriately sized to this fog type of fog devices to run on. So, security is also a major issue. It is not only that the data can be compromised, the fog devices may be a platform to simulate or launch attacks, right. So, because it is distributed, now things are distributed, less control over this centralized cloud and the ISP. So, there is a chance of this being exploited. So, need to be looked into things are there. How secured or how robust these fog devices are also a major challenge, people are working on that. With this, we let us stop today. So, what we discussed that the importance of fog, amalgamation of the fog and cloud, that is, it is not like that throughout one of the technology things are there, rather proper synchronization and orchestration between them is the real way to have a successful implementation of this framework. Thank you.